Okay, so for this problem, we're saying, are you guys with me? Um, we're saying that this is 50 because the observer is always 50 feet from the balloon, right? So, or the starting point, or wherever the balloon takes off from. This is on page 196, just for future reference when I give this to another class. And not make a mistake on it. How exciting. So on page 196, number 35, he's 50 feet from it, but he's not going to be moving towards or away from it. It's just the balloon that's moving. And the balloon's rising at a rate of 4, so I'm using y because, y is up and down, right? And that's just going to be a changing thing. We know where there's a balloon at the top of this triangle, and dy dt then is equal to 4. So that makes sense. So now let's think about what else they want to know. They say find the rate of change of the angle of elevation, and they say when the balloon is 50. So when the balloon is 50 feet up, when y is equal to 50, that's when we want to find d theta dt. So everything here should be good. So if we're going according to dreads, we have a diagram. We have the rates in a box, and we now need an equation that relates these three variables, or these three things, which I guess one isn't a variable, which is kind of nice. So what trig function relates these? Yes? Tangent. So tangent of theta is going to be our useful equation here, opposite over adjacent. And that means that we could, even if we want to avoid like maybe accidentally doing a quotient rule, we could probably just do 50 tangent theta. You know what I'm saying? Yes.
So, like you only really use tangent for all of these, right? Like you'll never use a different trig function for it, like.
Well, for these you could always use something different, but tangent seems to be the most useful because usually we're looking at something that's either like a ladder that's fixed or something like that. Tangent seems to be the most common, but it could definitely be another trig function. It could certainly. Even though the 50 isn't the one that's changing, that's okay. You can still use tangent, exactly. Unless they ask something, if they gave some information pertaining to how far the guy was from the balloon, which is now this, but they haven't talked about this at all on this equation, so I'm assuming I don't care about it, and that means I can just look at this, which is a lot better. So that's where we're at. Yes? Yes. Right. You shouldn't write it on the diagram. The only reason is because it's not constantly 50, so it could be confusing. So I put the 50 over here, just FYI. It's over here, but it's when y is equal to 50. So I don't like to put it on the diagram. You can, but it's strongly frowned upon. It's recommended against. So now we've done all the things we need to until deriving. So now we can derive this equation. And let's presume our deriving skills are good. We got 50 secant squared of theta d theta dt, okay, is equal to dy dt. And that's really where we're at. And now we say, okay, well, I hope that I have all of the things I need to get there. So I have dy dt. I don't have much else. So I have now, let's see, I have 50. I need to find secant of theta and then square that, whatever the heck that is, d theta dt. Now d theta dt we know we're not going to find. We're not expecting to find that. We were not surprised to find that that's an unknown. But the real deal is, how do we find secant squared of theta? Well, how can we get that at this very moment? This is now at a moment. You've derived. You can finally plug in. How do we find secant squared of theta? Yes? You just look at the triangle and think about secant of theta. Now we could put the 50 on, Emma. At this point, I would be cool with that, because now we're looking at a fixed triangle, and this is 50 root 2 by special right triangles. So what is secant of theta going to be in this triangle, in this world, right now? Right, so secant is hypotenuse over adjacent. So hypotenuse is 50 root 2 over 50. So I want to say that secant of theta, just secant of theta, is equal to just square root of 2. Right? Because it's not going to be adjacent over hypotenuse. It's going to be hypotenuse over adjacent. Cancel, cancel, just square root of 2. We want secant squared of theta. So we just want 2. So we now have 50 times 2 times d theta dt is equal to 4. So 4 over 100, or 1 over 25, should be, and this should be in radians per whatever our unit was, should match up theoretically. So 1 over 25 radians per, what is it, minute or seconds or hours or what was it? Do we remember? Seconds. So it should be 1 over 25 radians per second. And guys, it's actually the correct answer this time. How exciting is that? So for some snaps for that, and we'll wrap up this video right there. So there's your basic trig. This one's a little bit nicer than the last one. This is probably where I would expect you to be. Try to be this good. Try to be at least this good, okay? We'll stop it here.